entrance of the oocyte. This is the fertilization. You can see, as I told you, the sperm pass between the corona radiata. After that, zona reaction, phase 2, acrosomal reaction. Phase 3, you can see that sperm entrance to the oocyte except the membrane of sperms. The sperm fertilize the oocytes, and now I want to continue about what's happened after fertilization. After the fertilization, the two temporary membrane is produced around the genome of father and mothers. For example, the blue one is male, the red one is a female. We say that pronucleus. And after the recombination, the first mitosis apparatus is here. The first mitosis apparatus is established, and the first mitosis happens. Finally, we have two cells zygotes. Each of them is named is blastomer, and each blastomer has diploid cells, because here we have a resumption of diploid. Is it clear? And this is a two blastomers. We say that two cell zygotes. As I told you, the two pronucleus, two PN or two pronucleus. The fertilization, be careful, the fertilization is happening in the ampullary region of the uterine tube. Do you remember the ampullary region? Yes. The site of fertilization is the ampullary region. And after the fertilization, the embryo start to move toward the uterine cavity. And the first steps, we have the two blastomers. This is the two cells. Zygote. Okay? This is situated in the uterine tubes, and after that, draw the simple picture because it's a very large process. I draw a smaller one because I need to move spaces. Zygote. Each of them is named blastomer. And after that 4 cell stage and 8, 8 cells and be a T2 is a name Nurula. It's like a roseberry, we say that Nurula. Okay? And this is a pathway. This journey is taken on the 6th day, and when the embryo is receiving here, the polarity is started, the sun cells situated in the centers. You remember the first
inner cell mass.
Yes, inner cell mass, exactly, I told you that. And some cells around the embryo here, outer cell mass. This is a zona pellucida. This is a blastocyst. And usually the more than 60% placenta implantation is happening in the posterior superior wall of the uterus. That size that I marked here. This is a look at the picture, please. Look at the size of embryo from here to Nola. We don't have any change of the size of embryo, but in any division, the size of blastoma is smaller. Okay, and the 8 cells, one important mechanism is happens. What does it mean? It means that the central cells be a flat shape, and that cells situated in circumstance, they are all circular. We say that the compaction is a compaction because when the central cell be flat, they started to more communication, making it one of the most important junction that for the exchange of the material and ion. The spatially gap junction. You know the gap junction you use in embryology? Okay? This is the starting of polarity. Start of polarity. Because in the next step you can see that we have a polarity. We say that this central cell, his name is inner cell mass, and that surrounding cell, his name is trophoblast. If you replace these cells in this stage, for example, to bring one cell from the circumstance to the center and vice versa, the fate of the cells is changed. It's like human. For example, if you bring the one baby from the Afghanistan, for example, and you that baby will go to the USA or to the England, okay? The fate of the baby is changed. The embryo is happy. The site of the cells make the future phase. Okay, started of polarity, his name is compaction. In humans, this mechanism is happening in the 8th cell stage. Is it clear?
The compaction becomes the inner cell mass? The compaction becomes the inner cell mass?
No. Before the cell mass, here. It started from here. Okay, they started and the increase, and finally you can see in this stage. Because the fate of these cells now is completely different, the fate of these cells. These cells, his name is embryo. All of the tissue in our body, ectoderm, mesoderm, and endoderm made by inner cell mass. But trophoblasts only make the placenta. Only placenta, not anything else. And here, till here, we say that all of the cells are totipotent. But when we receive in here, inner cell mass is not totipotent. Pluripotent. Here the potency is decreased. Because before in the blastocyst, each blastocyst can make everything. But when the blastocyst is formed, the trophoblast never make ectoderms. Is it clear? The potency is decreased. And after that we have multipotent. In our body we have a multipotent. But in our body we don't have pluri and poly. Which tissue in our body is a multipotent? Bone marrow, exactly. Because bone marrow making the RBC, YBC, and many type of YBC. And unipotent. Please give me example in our body about the multipotent.
Monoblast.
Huh?
Monoblast.
No. It's easier.
Results.
Spermatogonia stem cells. Huh? In
Actually,
the male, after the puberty, spermatogonia continually make a sperm, is a stem cells, but only make a sperm, not anything, not any cells. And the skin, the basal cells, every day in the uterus. Huh? In each cycles, how the endometrium is repaired in the next cycle. Potency, because the base of the gland of endometrium, look at me, the base of gland of endometrium has its stem cells, and every cycles, again, these stem cells proliferated and repair the endometrium. Huh? Is it clear? In the GI tract, and every tissue except nervous systems, we have a stem cells, unipotent stem cells. Except nervous systems in adults. Okay, that's all. The first week is finished. And this division, what is the name of these divisions in the embryo? It is a mitosis, but here we have exception. We produce one unique term. We say that cleavage. Cleavage is a mitosis. I'm sure that you read it guys, huh?
Yes.
Cleavage is mitosis in the first week. His name is cleavage. Okay, now the embryo have to implant it. Before the implantation, is last step is happened. Gradually the ZP be teen and finally it ruptures. Till to implantation, ZP is remained. ZP has two functions. The one main function that you know, ZP layer. What the main function of ZP?
The cortical.
Specific receptor, no, a specific receptor for their own sperm species. Huh?
Yes.
What the next action? Prevention of
Polysperm.
no, the polysperm is called
Ectopic pregnancy.
exactly ectopic pregnancy. If it's ruptured sooner, the embryo implanted in another site, not in uterus. For example, if it's ruptured in here, in the ampullary, it's remaining here in the ampulla and implanted in uterine tube. The most common site for the ectopic pregnancy is ampullary region. That site that fertilization is happening. Okay, the next role of the ZP is prevention of ectopic pregnancy. It has to remain till to the end of the first week. When it's ruptured, it's interesting. It has interesting features. Look at me. This is an inner cell mass. This is the outer cell mass. The ZP. This is a ZP, and this view we say that this is a hatching. It looks like a chicken, huh?
yes.
When they broken the eggs, the shell of the eggs, huh? the chick is coming out. The embryo is look like a chick. We say that hatching. The embryo doing hatching. It's coming out from the ZP. How it's happened? By secretion of trophoblast cells. Trophoblast cells has an enzymatic behavior, produce the enzyme. And this enzyme causes the case of thinness and finally broken of the ZP. Okay, that's all. And at that time, on the surface of the trophoblast cells, one receptors, two kind of receptor, L-selectin and integrins, are expressed on the surface of trophoblast. Again, like a key and lock. Huh? On the surface of endometrium, receptor and ligand. It is a crosstalk. They have a sense of interaction or crosstalk between the embryo and the endometrium. And embryo attached to the endometrial wall and started two penetrations. We say that implantation has 3 stages. One of them, apposition. What do you know about apposition?
The trophoblast invades the endometrium.
No, apposition. Apposition, attachment, and invasion. This is an implantation. Embryo attached from the inner cell mass side, from this side, not the another side. Huh? You return it, it is the opposite. It is an embryonic pole, it is an ab-embryonic pole. It means that when you want to attach, first of all rotate, because it has to attach from the inner cell mass side. Is it clear? This is the opposition. Huh? Because we want to embryo correct the position of attachment. The next step is attachment, and the second step is penetration. For example, this is a uterine wall. This is an embryo. This is the inner cell mass. It has to rotate, and this side. And when it's attached, okay, and after that, it has to penetrate it, go to into the wall. Huh? Because it's not acceptable, it remain on the surface. Because we want to doing a communication with blood circulatory systems. Is it clear? Yeah. And after that, embryo started and penetrated. And I have a question: why the embryo is not rejected by the mothers? Because we have a half of the chromosome from the fathers. And this embryo, now it is a fine tissue. Why is not rejected by the mothers?
Is it because of the recombination during the...
No. Have you read everything about it?
I think it's because the antigens that recognize the male as a foreign particle, which are not present in the male cytoplasm, male cell, because they are already reduced during spermiogenesis. The antibody is present in male cells. Only the male nucleus comes in touch, not the entire cell. So we don't have a
So
foreign
half
particle.
of your theory is correct and half of it is not correct.
I think like DNA is
Not related. The first part of your speech is correct. Because of in the surface of the embryo cells, we have a different kind of antigens. Because in our body, in other cells in our body, we have a different antigens, but here the antigen is completely different. We have a HLA type G. is a completely different antigens. That's one. And we have a main reason. One of them is one of the main reasons. Another one is a suppression of the immune system of the mothers. The natural killer cell, okay, the suppress. This is another reason. The third reason is we have two type of T cells, T1 or T1 and T2, okay? The T2 is increased in the time of implantation. Normally we have more T1, okay? This balance, okay, is changed. Okay, suppression of immune system of the mothers, suppression of natural killer cells, different antigen on the surface of the cells, especially trophoblast. As a result, the mother's immune system cannot detect and cannot defense against of the embryo. Is it clear? Okay, the next steps. The first week is finished. Now we go to the second week. For example, this is endometrium. This is an endometrium. And this is a site of implantation. This is a compact or functional layer of endometrium. Here is endometrium. Functional layer of endometrium. Here is a blood cell of the mothers. Blood capillary. Okay. The embryo is come into the start penetration. The first of all, the inner cell mass, as I told you, make two layers. Huh? Please tell me the name of the two layers. Epiblast and hypoblast. Do you remember? And first of all, here this is the blastocell. Blastocell. And the first layers. First cells originated from the epiblast. That name is amyloblast. And the first cavity, that name is amyloid cavity, is establishing here. The amyloblast produced or originated from the epiblast layers. The outer cell mass, it's produced in next layers that may be cytotrophoblast. Cytotrophoblast. And this is a syncytial. This layer is produced by the cytotrophoblast. The border of syncytial trophoblast is not clear because in the cytotrophoblast the border of cells is clear. Huh? Yes, this is the border of clears, but the border of syncytium is not clear. The syncytium is produced by cytotrophoblast. This is at 7 or 8 days after the fertilization. Okay, we go to the next days. The site of implantations is closed by one tissue, fibrin coagulum, by fibrin coagulum. Because it's not be open every time. We have to close the site of penetrations. Huh? Okay, what's happening the next? The amniblast is hard, we have it. A new layer is produced by hypoblast cells. That name is Husserl membrane. Husserl's membrane. Okay, Husserl's membrane,
So
or
what about the
exocelomic membrane. And the new cavity, that name is pre-methyl dioxide. It means that blastocell replaced by new cavity. Before that, we say that blastocell. And by establishment of Husserl membranes or exocelomic membrane. We have a two exocelomic membrane is not important. Exocelomic or Husserl membrane. The new cavity is formed. We have a trophoblast in here. Syncytium, but some cavities appear in here. That name is lacuna. This is a 9 days. 9 days is famous to lacunar stage. Look at the difference. The embryo will be larger. It's coming more into the uterus. Okay. The site of implantation is closed by a temporary tissue that name is fibrin coagulum, and some cavity, because before that stage we don't have cavity in syncytium. And small cavities appear. The cavity, the Latin word of the cavity is lacuna. Okay, the small cavities appear in syncytium layer. Is it clear? A new cavity is formed. That name is primitive yolk sac.
Sir, can you please repeat?
This one? I told you before that stage we have a blastocell. Huh? From the hypoblast cells, a new layer, new cell is formed. That name is Husserl membrane or exocelomic membrane. When this membrane is formed, a new name we give to this cavity. Primitive yolk sac. Is it clear? It's easy or not?
Easy.
Easy boy.
I will ask.
In the next step is difficult, okay? When I want to change the embryo to 3 gel layers. Because now it's embryo is bilaminar gel disc. The other 2 layers, epiblast and hypoblast. Okay, next steps. Next step. We go to the 11 and 12 days. 11 to 12. Well, we have again fusing coagulum. What's the main difference now? Huh? Can you tell me what the main difference?
You have a new cavity of fibroblast. There is no gap.
We have one gap, huh?
Yes.
Here, between the, what is the name of this one? No, this one. This is a lacuna. Huh? What is the name of this one? Cyto, and this is an embryo. Huh? We have one gap. Look at my hands. First of all, this gap filled by a new tissue. This is a new tissue. It's produced by epiblast cells. Huh? This new tissue, his name is extra embryonic mesoderms. Extra embryonic mesoderm. These layers, it's up here around the embryo because this ball, his name is embryo in the center. It's produced by epiblast cells, but gradually a cavity is formed. A cavity is formed in here. And gradually, one cavity is forming here, and we accept that regions, except here. Here we see that, we say that connecting stalk. In the future, this connecting stalk make umbilical cords. When the cavity is formed, the mesoderm divided in 2 parts. These red parts, these green parts. And one cavity. The cavity is named extra embryonic cavity or chorionic cavity. Chorionic cavity or extra embryonic. Both of them the name. And these green colors, this one, his name is splanchno-chloric, and the red one, his name is somatochloric. It means that extra embryonic by formation in one cavity divided in two parts. That one covers the top of the amnion cavity. The red color, please. This is important. And the inner spool face of cytotrophoblast, his name is somatic layer. Both of them is extra embryonic. The red one somatic, the green one only covers the stool face of your sac. Huh? Is it clear? Here I write it. The red one is somato, the green one is splanchno. Both of them, and this cavity, its name is extra embryonic cavity or colonic, the synonym. And but the most important part in this day, the first contact between the blood capillary and the blood capillary drain to the for the what the name of this cavity?
Laguna.
This capillary is name is spiral artery. Espiral. Spiral artery. Yes, spiral artery. The spiral artery drain to the lacuna. The first communication, first contact between the blood system of the mother and embryo, it's happening these days. 11 to 12 days. We say that utero placenta circulation. Which days utero placenta circulation is happen? Because before that, look at me. Before that, the embryo nourished by the diffusions. We don't have the contact between these capillary. You remember? This is a blood capillary. But at that time, embryo penetrated more, be larger, and at the result, destroy the capillary of the mothers. And these capillary drain to the lacuna. The lacuna is formed one or 2 days before. Is it clear? And the end of the second week, the site of implantation completely repairs. Before that, we have a fibrin coagulums. You remember? And it's completely. One thing is happened that the first the colony cavity be larger and larger, and the first all of the lacuna filled by the blood vessels. And the first yolk sac is degenerated, and secondary or definitive yolk sac is established or produced. Secondly, or this is a colonic cyst, and finally is degenerated. The colonic cavity be larger. Look at the size of the colonic cavity here. The definitive secondary yolk sac is produced. The site of implantation is repaired. And at the time of repair, we have a small bleeding. The mother observed a small bleedings. This bleeding is completely different with bleeding as a menstrual cycle. Why? Why is difference? And maybe it's mistake by others. This bleeding with the menstrual cycle bleeding, but it's had a big difference. What the days? This is a 13 days. The 13 days in the menstrual cycle is approximately, it's according to 20 days of menstrual cycles. Do you understand me?
Mm-hmm.
Because the fertilization is happening in 14 days, huh? If its fertilization is happening 14 days, 14 plus 13 is equal to 27. Is approximately according to the start of the next cycle. Okay? And the model may be mistake.
Yes.
But here is we have one big difference. The amount of the bloods in this bleeding is very, very small. Around 20 to 30 milliliters we have a bleeding. But the volume of bleeding is 130. Okay? We have a long bleeding with larger volumes. Is it clear? Okay, the second week is finished. We say that second week is the week of, we have a rule of tubes. Everything be a tube. What does it mean? Inner cell mass make a 2 layers. Epiblast, hypoblast. Outer cell mass make a 2 layers. Cytotrophoblast, sensitotrophoblast. Huh? We have a 2 layer of the extraembryonic mesoderm, divided 2 layers. Splanchnic, somatotroph. 2 yolk sac is false, primary or secondary. Okay? All of them, we have a rule of tubes. Is it clear? That's all. Take a rest. The second week is finished. And the one table, you can see all of the events of the second week. In the next topic is difficult. Okay. Because now we say that this is a bilaminar gem disc. Why we say the bilaminar? Because the epiblast, the hypoblast, both of them making a 2 layers. We say that like a cake, bilaminar gem disc. In the next step, I want to make a 3 laminar gem disc. In the next topic, I talk how this bilaminar change to the 3 laminar, how we make ectoderm, mesoderm, and endoderm.
Mr. will complete the third week today. Complete the third week today.
No, I think that the first of all, I have to stay in here for 2 days, but the international office changed my timetables. to the 1 days, maybe the next session, 2 or 3 weeks later. Maybe. If it's not coming back, I uploaded some movie, my lectures, like a class.
So we have sessions tomorrow?
No. Another session, maybe I will come back next or 2 days later.
Maybe it's 16 or 15.
Maybe or upload some film in Navis.
So we don't have lecture tomorrow, sir.
No,
So tomorrow done?
No, the tomorrow is I have to come back to the job.
Tomorrow done.
Tomorrow you are off. And in the schedule tomorrow we have a class, huh?
Yes.
Yeah. According to how many hours?
6
Team new.
Two session.
Three.
Do you want it? Who's presenting? Class tomorrow. Do you want
Finish today. The sessions that are limited for today.
Okay, we review together, please. We review together the slides. Here you can see that the bilaminar jaundice, I told you about that. Finally, bilaminar jaundice have to change to the 3 laminars. Okay, the layer of embryo. Also, I describe amnion cavity, amnion start connecting start in coils. All of them, as you know, is formed during the 2 weeks. There's the time of implantation. Look at here, this is 7 days. The blastocyst, epiblast, fibroblast. Why implantation is happening? Because the syncytial trophoblast secreted proteolytic enzyme. Okay, all of passage of the uterine, totally surrounded, and I told you all of these things. I give the slides for me. This is a real picture from the embryo. This is it, 8 days. The more implantations, the syncytial trophoblast is formed. The first cavity, amnion cavity is formed, you can see here. This is at 9 days, lacunar stage. You can see the cavity in the syncytial trophoblast. Is it clear?
Yes.
The Husserl membrane, look at the formation of the new cavity. When its Husserl membrane is completed, the new cavity here is in primitive yolk sac. Formation of Husserl membrane. And temporary closing of the site of implantation, coagulum, plug or filling coagulum, the same.
And the lacuna are formed.
Huh?
The lacuna are formed.
The lacuna is important events in the 9 days.
So the Husserl membrane is formed by the hypoblast, right?
Yes. You can see here, the red colors is originated from the red colors. The 10 and 11 days, you can see the extraembryonic mesoderms. Here, right extraembryonic reticulum, no problems. The same. These colors. And uteroplacenta, look at the communication between the blood capillary of the mother with the lacuna. The lacuna filled by the blood from the mothers. You remember uteroplacenta circulation and formation of extraembryonic mesoderms. Look at the extra embryonic mesoderm in here by epiblast, splanchno, and somato. Finally, extra embryonic mesoderm has 2 layers, and the cavity is formed. That is the extra embryonic cilium or chorionic cavity. Real pictures from the embryo, the same situations. The 13 days, look at it. The exocellular cyst, a new yolk sac cavity is forming here. A new one. A new one is named definitive or secondary yolk sac. Is it clear? What that means? Huh? Finally, you can the first yolk sac be a one cyst, remnant of primitive yolk sac, and the new one is formed, definitive yolk sac, and chorionic cavity will very large. Okay, the real embryo, and finally you can see here. This is a remnant of the primary yolk sac in here. The lacuna filled by the mother bloods, and this is the embryo, and this is the characteristic spot. Okay, that's another pictures. This is another theory. You can see if it is two sperm fertilized oocyte, what's happened? We have a triploidy, and in this situation only the embryo is failed. Because we have an extra copy of the chromosomes. But maybe it remains 2 months because the placenta is full and secreted HCG. HCG is one of the signs of the pregnancy. Yes, human chorionic gonadotropin is produced by trophoblast, and you can detect it in urinary of mothers or the blood of mother. Is a main sign of the pregnancy that it's happens in one reliable test for the pregnancy. Sometimes the sperms fertilize oocytes, but before the fertilization we lost the oocyte nucleus. It's not the reason why. And only sperm is remain. Because the red color is the nucleus of the mother is lost, and the sperm, the blue one, is remain, and replication is happen. And finally, we have one embryo that diploid, but all of genome belong to the fathers. This is a hidatiform hormone again. It's not developed. It's like a tumors. Okay. This is an ectopic pregnancy. I told you this is the site of ectopic pregnancy. The X is a normal site. All of the region is ectopic, but the most common is a ampullary region. It is implanted in the cervix. We have a placenta previa and many abnormality. Some question for what are you reading? Which of the following is derived from the epiblast? For example, my final question. Okay, now I put all of the slides in the desktops. Next. Okay, and now I want to talk about another topic. If you want to make a trilaminar gerlis, it's happened in the 10th week of gestation. The formation of three laminar gel is happened by this mechanism. Gastrulation. Gastrulation is a mechanism or process that two laminar gel, this change to the three laminar gels. This is a new term. Gastrulations. Before the gastrulation, you see the embryo is look like this one. It's like a ball, has two diameters. The one layer is an epiblast and one of them is a hypoblast. These two layers separated two cavities, amnion cavity up to the epiblast and yolk sac down to the hypoblast. Look like this one. For example, the blue one is epiblast, the red one is hypoblast. But what's happened, is not clear which mechanism, but some texts say that this is a epiblast cells, this is a hypoblast, amnion and yolk sac. If I cut this top of this amnion cavity and I stay in here, I look down, what the name of this layer?
Epiblast.
Epiblast. This is all of this layer. Where is the hypoblast? It's under this. Is it clear? It's not clear, but we say that some fibroblast growth factor number 8 causes establish one grooves in here. That name is primitive groove, or primitive streak, primitive pit, primitive node. What does it mean? Look at the floor of this class. Here we have some tile. If we, in the midline in here, for example, this is a midline of the class, all of the tile in here is epiblast. Epiblast cells. You imagine this cavity is amnion cavity. All of the students standing on the amnion cavity. This is the amnion membranes. And under these tiles we have some brick, another layers. And what the name of that? Hypoblast. Hypoblast. Epiblast and hypoblast. And under the hypoblast we have another cavity, that is a yolk sac. I'm standing on the epiblast layer, you're sitting on the epiblast layer. You imagine this midline tile exactly here. It's going down and making one groove. This side is remains, but in here is going down. Like a fiction films, okay? These bricks opens to each others. Have you seen some fiction films? The floor first of all go down, going depressions and making one grooves. We say that primitive grooves or streak. And when it's going the middle, this depression will be large, circular, like a pool. That is primitive pit. The edge of pit, you never learn in the homes because it's difficult. You have to learn in the class. The groove is happen, the depression is circular like a small pool, okay? We say that primitive streak, primitive pit, and between the brick, the tile is open like a fiction films. These epiblast cells started to proliferation and go toward the groove and going down. This is mechanism is interesting. Is it clear? We say that this is a epiblast migration through the. Look at the picture I draw it. This is a streak. The arrow shows the pathway of the migrations. This is a coronal section. The cells going down. I draw it. These cells going down. If I draw the pictures again like this one, after the formation of primitive streak, this is the epiblast cells, this is a hypoblast, and that cells going down. First of all, they replace the hypoblast cell replaced by this cell that's coming down from the epiblast. This is the epiblast. And when it's settling here, the new layer is here, its name is endoderm. Okay? The hypoblast is degenerated. A new cell that coming from the epiblast settle in the hypoblast layer. Is it clear? When the roof of yolk sac is finished, completed, the next wave of the cells is coming in the needles. It's coming in here. The next cell is coming here. The next wave. And make a new layer here. Its name is an embryonic mesoderm. The first wave migratory cells make endoderms. The second wave make and when an intraembryonic mesoderm is established, like a fiction film, the groove is closed. Everything is clear. It's finished. And remaining epiblast cells, now we say that this is ectoderms. Is it clear? Finally, in conclusion, we say that all of the three germ layers, means ectoderm, intraembryonic mesoderm, and endoderm, originated from the epiblast. Is it clear? But that cells going down from the pool, here is a pool, pits. That cells going straight forward only, not that cell go down through the street. That cell go down to pits. They go straight forward. They make two structures, precaudal plate and notochord. Only that cells, not these cells. These cells going down this like this one. Precaudal plate and notochord. I showed that notochord. Finally, that pictures will look like this one. After everything is finished, the picture number 1, the picture number 2, the picture number 3, I brought in here, excuse me, because I don't have any spaces. Yes. This is an intra-embryonic mesoderm. And this is a notochord. Because this notochord situated in the same level of the intraembryonic mesoderms. And notochord, I will tell you in next session, that is important in the
Nervous system.
No. Exactly, the formation of the nervous systems and formation of the vertebral columns. If you remove the notochord, what's happened? The nervous system never develops.
Spinal cords, you know.
If you put in the cheek, some scientists do it. If you bring the notochord from another cheeks and put in the one embryo, and if the embryo has two notochord, what's happened? We have a two brain and two spinal cord. We say that notochord is the organizing center because the notochord organizes many systems like the CNS, like the vertebral columns. Or we check if there are some slides. Look at the pictures, please. The yellow color, the first wave of migratory cells. They're making the hypoblast. The red color, the second wave. Look at the pictures. These red cells making the intraembryonic mesoderms. Look at the primitive state, please. But primitive keep that cells migrated from this cavity, they go straight forward, they're making a notochord. The picture shows the pathway of the migrations. That one migrated fast forward only, these cells making a notochord. Only these cells. Is it clear? The primitive sticks. That one. The purple, look at the purples. Notochords. But in front of notochord we have another term, precollar plaque. Both of them migrating from the primitive pits, but only the time of migration is different. The first cell that migrated, his name is precollar plaque, and the second wave that migrated is a notochords. And for the this is the ectoderm, mesoderm, endoderm in the mice. And what do you think about it? Look at it and read the topics. I told you that primitive stick is started to the occurrence in the 10 weeks, and the closing of primitive stick is finished in the end of the 10 weeks. If it remains more than the 10 weeks, what's happened?
More cells will go. More cells will migrate.
Most cells migrated. But the last wave is mesoderms, and we have excess mesoderms. We have more than mesodermal cells. Is a tratoma. Do you remember I showed that this picture in the rest of the class? Was there another reason the tratoma? When the PGC had an abnormal migration. The same results. Now we have two reasons for the tratoma. Abnormal migration and the remaining of primitive stick more than 1 week. Primitive stick function slowed down. It undergoes degeneration. Some remnants may persist of the tratoma. About the notochord, I told you about notochord, the picture. Look at the pictures here. For the formation of notochord, first of all, notochord is hollow tubes or process. But with attachment to the endoderm, the final notochord be definitive notochord. Look at the picture in your right side. In top of the pictures, we have a notochord, but it's hollow tubes. But in the end, what do you see? It's solid tubes. If it's hollow, it doesn't have a function. It has to attach the notochord and separate it. And in this mechanism, we have a temporary communication between the aluminum cavity and yolk sac that may endure canals, but is temporarily closed. This mechanism. This is the notochord is on, and finally, that is the interesting pictures. The 3D pictures. Look at the notochord in here. This is a mesoderm, intraembryonic. The yellow one is an endoderm. We divided to intramesoderm, embryonic mesoderm to that pulse. Paraxial is near to midline. Intermediate and lateral plates. Both all of it is intraembryonic mesoderm, but it's separated into three parts. Paraxial, intermediate, and lateral. This is in notochords, and this one is ectoderm, the blue one. Is it clear? Paraxial mesoderm, intermediate mesoderm, and lateral plates. I will tell you next session that that's all divided to spanning somatics. Again, the pictures show after the gastrulation, the embryo will look like these pictures, the top A pictures. Is it clear? The top after the gastrulations.